Okay, number 5 here. Two, and this red line, this is indicated by these red lines, these are called tangents. So two tangents from a single point, which is this point here, have equal lengths. And we don't mean the length of the whole tangent because it carries on forever and ever up here and up here. It's the point at which the tangent touches the circle. So that means we've got this distance here, AB, and this distance here, AC. They're equal. So two tangents from a single point have equal lengths. Number 6, well, what is this red line? This is a tangent. And it meets the green line is a radius or a diameter, so that could have been extended up to there to a diameter, but they meet at right angles or at 90 degrees. Okay, so a tangent meets a radius at 90 degrees, or a tangent meets a diameter at 90 degrees. So number 7, what we have here is a quadrilateral, a four-sided shape, where all four corners, and that's important, all four corners touch the circumference. If that's the case, then these opposite angles add up to 180. So this plus this, A plus C, is 180, and B plus D is 180. Okay, so opposite angles, and this shape where all four corners touch the circumference is called a cyclic quadrilateral. Cyclic because of the circle, and quadrilateral because it's a four-sided shape. And they add up to 180 degrees. Don't say that they are 180 degrees, because they're not. They add to 180 degrees. In other words, A plus C equals 180, and also B plus D is 180 degrees. Number 8. Now this is the most difficult. Let's just fill in the green and red lines here. So the green line, well, this is a chord. So we've got a chord here. And we've got the red tangent. Okay, now this circle theorem is called the alternate segment theorem. And I'll explain why it is called that now. The alternate segment theorem. Now, for all of the other circle theorems that we've looked at, the first 7, you basically need to know these words. Tangent meets a radius at 90, or two tangents from a single point have equal lengths, or angles in a cyclic quadrilateral add up to 180. Sorry, opposite angles in a cyclic quadrilateral add up to 180. You need to know those. Now, the text that I've written here, you don't actually need to remember, but it does help you understand what the alternate segment theorem is. Let's read it. A chord that meets a tangent subtends an angle. So the chord is subtending an angle. So here we go, it's subtending this angle here, this angle called x. Okay, a chord meets a tangent, the chord subtends an angle in one segment. So this is the segment that it's subtending it in, is equal to the angle created between the chord and the tangent in the alternate segment. In other words, not the segment that we did before, the other segment, the alternate one. So chord subtends an angle, and that chord is meeting a tangent. It subtends an angle in this segment, and the angle that it creates between the tangent and the chord in the alternate segment is equal. So these two are equal. Let's do another example of that. So let's say we've got a circle and a chord meets a tangent. The chord subtends an angle. There we go. Oops, that should have joined them there. And that angle is equal to the angle created between that chord, the one that subtended the angle, and the tangent, in the alternate segment. In other words, not in this segment, but in this one. So it's this angle that's created. Let's do another one. So here we have a chord, and the chord meets a tangent. And let's say the chord subtends an angle there. that's equal to the angle created between the same chord and the tangent, but in the alternate segment. Another one. This is all alternate segment theorem. So let's say this time we've got a chord meets a tangent, and the chord subtends an angle there, and that angle is equal to the angle between the same chord that subtended the angle and the tangent, but in the alternate segment. So it's that one. Okay? So there are the circle theorems. And you need to know those. You need to know the alternate segment theorem, the words alternate segment theorem. Understanding these words is useful because it helps you understand what the alternate segment is trying to say. You don't have to remember those words. Important thing is, if you see a tangent and it meets a chord, you should really be thinking about alternate segment theorem. Okay? So, in particular, a chord that meets a tangent should spring into your mind the alternate segment theorem. Chord meets tangent. If the chord subtends an angle, then it's equal to the angle between the same chord and tangent, but in the alternate segment. Hence, alternate segment theorem. Now these all can be proved, but I'm not going to do that in this video. We are going to look at some questions next.